Hi everyone, so in this video I'll be looking at how to use the Casio FX CG50 to help you work through or check your answers for the Corbett Maths booklet on exponential graphs. So looking at question number 1, it starts off with our table of values. If you've seen the other videos now, you're kind of used to that because we've done that a few times. So let's go into table. If I'm going too fast for you, please do refer back to either my drawing straight line graphs, my drawing quadratic graphs, or even my drawing cubic graphs videos to help. The last one we did was 15, so let's do this next one. Now this is y equals, which is already there for me, so I go 3 to the power of x, which is different. We haven't done that yet. I'm going to set my table from -2 to 2. And let's have a look at the table. So here we go. So I've got -2 is 0.11 recurring. -1 is 0.3 recurring. 0 is at 1, 1 is at 3, and 2 is at 9. So I now need to draw that graph. So I'll draw the ones I know more precisely first. So 2 is at 9, 1 is at 3, 0 is at 1, and then I need to go a third of the way up a box, and I need to go a 10th or a 9th of the way up a box. What I must not do is touch the x-axis, because this will tend towards where y is 0 but never actually get there. The x-axis will act as an asymptote, and we'll come across things like that later on. So using my wrist as a pivot, turn it the other way up. Here we go. A nice smooth curve. There we go. And that is my graph for y equals 3 to the power of x. So let's check the next one. This one just asks me to draw the graph of x from -4 to 4, does not prompt me to do a table. So I do my own table anyway. Underneath. So draw your own table for this. It says -4 to 4. So we've got x is -4, -3, -2, -1, 0, 1, 2, 3, 4. Just because they don't ask you for it doesn't mean it's not a good thing for you to then do. There we go. Back here to table. So let's go exit. Oh, what I didn't do with the previous one is just check what that looked like. So, sorry about that. Let's go down. I don't want that one. I just want that one. Is that what I had in my answer? Just to a different scale. So, lovely. Let's go back. Menu 7. You get quite used to moving around between y equals 3 to the x, set my table, this time from -4 to 4, exit table. Remember, these are your gradients at each of those points. So -4 is 0.0123. -3 is 0.037, 0.1 recurring, 0.3 recurring, 1, 3, 9. So what I've done here is I've just recognised that the numbers are the same. So if I exit and I go back to that, I can just change it. There we go. Now my table's already set. I just go back in and change my values. 0.0625. 0.125, 0.25, 0.5, 1, 2, 4, 8 and 16. There we go. It's one of the benefits. If you make a mistake, just go back and adjust it. So menu, graph, let's see what that looks like. Good, 2 to the x. Let's draw that. So we've got a nice smooth curve. Once again, it gets ever closer. It tends towards that x-axis, but we'll never actually approach it. So what kind of a scale do we need? Well, we need our y to go from 0 up to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 squares, so that's rather handy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. X, I've got 1, 2, 3, 4, 5, 6, 7, and it needs to go up to 4, so I'm only going to use 1 square for each. They're not whole numbers, so I'm going to do the whole numbers first. 4 is all the way up at 16. 3 is at 8. 2 is at 4. 1 is at 2. 0 is at 1. Negative 1 is at a half. Then it goes to a quarter. Then it goes to an eighth. Then it goes to a 16th. There we go. Never touches the x-axis. So turn it around. This one's quite far apart now, so I am going to use my ruler for that one. And then I'm just going to connect the others with my curve. Like so. So that is, except for this bit here, I went a bit skewy. There, that's a bit better. So that's my graph of y equals 2 to the x from -4 to 4. And yep, so slightly different scale here. That only goes up to 9, but we can see the shape of it. If you want to, remember, you can change your view window. X is from -4. Actually, if I exit that, I'll do standard, because it's a 1-to-1 ratio there, and if I draw it, there we go. So that looks like it does here. You can still see that line. If I was to zoom in, it gets ever closer to the x-axis, and while it might look like it's touching it here, it's only because of the thickness of the line. But if you zoom in and go even further, every time you zoom in, you see that there's actually a gap between the two as we keep going for more further and further away from 0 in the negative direction on the x-axis. So that's question 2. Question number 3 is the same. Question number 4. Now this wants you to use simultaneous equations to do it. So let's have a look at this question. We need to find the values of a and b, and then we can draw it on our graph and our calculator possibly afterwards to help us. So y equals ab to the x. Here this tells me that when x is 0, y is 3, and when x is 2, y is 12. So when x is 0, y is 3. So 3 is a, b to the 0. When x is 2, y is 12. 12 is a, b squared. Anything to the power of 0 is 1. So 3 equals a times 1. Therefore a is 3. 12 equals ab squared. 12 equals, I've just found my value for a. So you can substitute that into here. 3 times b squared, divide both sides by 3. 4 equals b squared. Square root both sides. B equals plus or minus 2. Let's go back to the question. It says b is greater than 2, therefore greater than 0, therefore b equals 2. So I have a equals 3, b equals 2, and let's just check that here. So I'm expecting this to be y equals 3 times b to the power of x, or 3, that's where I got confused. I wrote b there. It should actually be the number 2. That's better. 3 times 2 to the x. So here we go. Menu, check I'm in graph. Excellent. Exit. So I've got here 3 times 2 to the power of x. Let's draw that one. Now I need to change my view window. Let's go back to my favourite, which is initial, and let's draw. Okay, so it hasn't sketched that one for me. Let's go menu. Let's go back. Y equals 3 times 2. Do you see here? I plotted it wrong. So I plotted it wrong, I entered it wrong. Let's delete that. Let's put an X in instead. Let's draw. Much nicer. Is that what we would expect? Exit. Here we go. 3 times 2 to the power of x goes through at 0, 3 there, and 2, 12 there. So let's just check this. Let's use trace. 0, 3. Good. That's what I've got. So let's trace again. 2, 12. Well, I might need to zoom out a little bit for that one. So trace 2, 2, 12. Perfect. So those 2 points lie on that curve. So I've got that one. So hopefully correct as much as I can check. Exactly the same for question number 5 and 6. The same approach for 7. And then 8 is asking you to draw that one. You have to do your own axes this time. It's very similar to question number 2. And then here, for each of the following statements, tick true or false. So that's one of the things we can do here. So let's go exit. Let's unselect that one. 19. Y equals 8 to the x. So 8 to the power of x. If I draw that one, if I use trace, let me just exit. Good, I've unselected the other one. Let's draw that one. I'm going to use trace. And I want to know if it goes through 0, 1. 0, 1 is on there. Excellent. So that one does. Next, y equals 3 to the power of x. So 3 to the power of x. Draw through the point 39. So trace 3. That's at 327. So that one doesn't. That one there is false. Then I've got negative 2 to the x. Oh, I've got an equation there, so I can just delete that one. So negative 2, that's in brackets, that's important, to the power of x. Draw, so I use my trace. Does it go through 3, negative 8? 3, negative 8, yes. Okay, y equals 5 to the power of x. Exit, unselect that one, delete that one. Y equals 5 to the power of x. Draw, does it go through negative 1, 0.2? So trace, negative 1, 0.2. Yes. Then I've got y equals 8 to the x again, passing through 0.01. Well, it's just repeated the first question. That might just be a typo. There you go. So there are 5 marks easily obtained by using your Casio FX CG50 to help you if you know how to do it. So that's the end of my video on how to use the Casio FX CG50 to help you check your answers or to work through the Corbett Maths booklet on exponential graphs. Thank you very much. Goodbye.